part we just talked about was the first derivative test and the second derivative test. And really the part that I just want you to focus on now is learning how to sketch graphs with the first derivative in mind and the second derivative in mind. This is what your worksheet that I'm handing out right now is all about. That's a little weird because I don't know how to hand it out, except luckily you have a sub. So thank you for that. So the biggest thing to take from things is f of x is your main guy. This is your derivative, which gives you everything about slope, positive slope, negative slope, zeros. You are super focused on your critical points here. And your critical points are when your first derivative equals 0 or it's undefined. The second derivative is all about curvature. And these you care about are inflection points. And that's when your second derivative equals 0 or is undefined. Okay. Now one more note to make on this. If I ever ask you for finding a root, that's when the regular guy equals 0. And roots, remember, are those. If I ever ask you to find a critical point, first guy equals 0 or is undefined. And those are these guys. And notice, I got a max here. This is just a saddle. This is where it's undefined, but it is a minimum there. So this is a hot. This is a hot. And that one's a ton, where the derivative is undefined. And if I ever ask you to find an inflection point, that's when my second derivative equals 0 or is undefined. And the whole idea of this is where you turn your wheel in driving. And just a basic example. Right there, everything before it is concave up, and everything after it is concave down. So at that green dot is an inflection point. So let's take a look at your worksheet. And we're going to try out number 2 first, and then I'll have you try out number 1. So number 2, 2A, locate any roots. I'm underlining this in black because that's on the function itself. So I'm looking at when is the function equal to 0? Or when is negative 3x to the 5th plus 5x to the 3rd equal to 0? Well, I can pull out an x cubed. So I got negative 3x squared plus 5 equals 0. So right away, x cubed equals 0. That's at 0. And also, it would be negative 3x squared plus 5 equals 0. That's when x squared equals 5/3, and x equals plus or minus the square root of 5/3. Okay? So, on my graph, if I wanted to start doing that, I already have one at 0. The square root of 5/3 on a calculator is, let's check, square root of 5 over 3 is about 1.29. So it's kind of right around there. That's going to be the square root of 5/3. And over here at negative 1.29, so right around there, is my other root. That question there, A, is only about the function itself. So now let's locate any critical points. I'm highlighting that in blue because that's all about the derivative. So I need to look at the derivative. Luckily, this is a nice one. Negative 15x to the fourth plus 15x squared. And I care about where that is 0. So when I do that, let's see. I can take out a negative 15x squared. And I'm going to get an x squared minus 1 equals 0. So x equals 0, or x squared minus 1 equals 0, which happens at plus or minus 1. Now, so what we've been doing this week so far is you can set up a chart. Let's see if I can do this pretty nicely. If I have 0 and plus or minus 1, I have 3 guys I care about, plus lots of blanks in between. 1, 2, 3, 4 blanks in between. So I need a 3 by 7. And I can pull this guy down. And let's see what we get here. I have x equals negative 1, x equals 0, x equals 1. I need to go get my y values, and if you notice, my y values are still in black by just plugging in, guys. When I plug in 0, that's easy, I get 0. When I plug in 1, I am going to get 2. Ooh, that looks a little bit small, so let me erase that if I can and put in a 2. And if I plug in negative 1, I'm going to get negative 2. And hopefully this isn't too small for you right now. Remember, I don't need anything here, there, or there, or there. My first derivative was 0 at each place here. And I now need to do sign checks. Now, personally, I would probably do my sign check, probably, you could do it right here if you wanted to. And throw it in there. So, when I apply anything really negative, this is always going to be negative because I have x squared, anything squared is positive, times a negative 15. So I'm going to have a negative, and now let's look. If I plug in a negative 10 squared is a positive 100, minus 1 is positive. So that's going to be a negative overall. If I plug in something here, I would try and plug in a negative a half, and it's going to be a negative. Negative half squared is small, minus 1 is a negative. That turns positive. And if you do check it, this one just bounces back and forth. Negative, positive. Let's check one more now. If I plug in here, it's still a negative. Something squared that's small, minus 1 is still a negative, so that turns into a positive. And this last one will be a negative and a positive, which is a negative. So I now know that it goes down, up, up, down. So if I want, I can graph these things. So I'm going to add in these points at negative 1, 2. Sorry, negative 1, negative 2. Negative 1, negative 2. And I'm going to add in 1, 2. And I have the 0, 0. It goes from a quick sketch looking would be this. This guy's flat. That guy's flat. That guy's flat. Now, from the earlier in this week, we can draw this graph. I just want to wait a little bit to draw it with the curvature. But let's right now draw what you assume it would be. So the way I would assume it on graphing this is it would go down, flat, up, flat, up, flat, down. That's what we've done this whole week. What we're going to add on top of this now is the second derivative. So we're going to take a look at that on the next slide. Or sorry, not the next slide, the next video.